Okay, so just continuing on some more of these examples, let's look at an example like this. Example where we have two stocks, two securities, and in the future they could either go, if the market goes up, they'll go to $1.20 and $2, or the market could go down and there'll be $1.20 and 50 cents. Okay. So let's just do the same exercise now where we're trying to figure out the price of the elementary security. So again, an elementary security is a security where if the market goes up, we get paid $1, and if the market goes to any other state, we get paid nothing. So right now there's two states, so it's a kind of trivial example. So how would we do that? We want to buy theta 1 units of, so if the market goes up, we would have 1.2 times theta 1 plus 2 times 2 times theta 2. We would have 1.2 theta 1 plus 2 theta 2 would equal $1, and 1.2 theta 1 plus a half theta 2 would equal 0. And then solve this linear algebra problem. Sorry about these. It's not writing what I'm writing. Okay. So if we were to solve this, we would end up getting 1.5 theta 2 equals -1. No, I'm sorry, equals 1. And therefore theta 2 equals 0.667, and therefore theta 1 equals, theta 1 would end up equaling -0.33 over 1.2 equals 0.275. So then the cost of the first security, the first elementary security would be, E0 would end up being 39 cents, 39.167 cents. Okay, so that would be the price of it would be for approximately 39 cents. We could get a security that if the market went to the upstate for 39 cents, we would get $1 in the upstate and $0 in the downstate. If we then wanted to solve the second elementary security, we would again do the 1.2 theta 1 plus 2 theta 2 equals 0. We want to know how much would we have to pay for a security, for a replicated security, that if the market went up we get 0, and if the market went down we get $1. So if the market goes up, we want 1.2 times theta plus 2 times theta to be equal to 0. And if the market went down, we'd want 1.2 theta 1 plus a half theta 2 to be equal to 1. We would solve this system of equations, and we'd end up with 1.5 theta 2 equals -1. So then theta 2 would equal -0.667. That was kind of like the last example. And then theta 1 would therefore equal, if you computed it out, would end up equaling 1.1083, and therefore the elementary security 1 would equal 0.4416. Okay, so this is really just another example of what we had done before. We have two securities. The market could go up, the market could go down. If the market goes up, this is what the securities will turn into. And if the market goes down, they'll turn into these prices. We'd like to be able to see if the market is complete. If the market is complete, that means all the elementary securities, and in this case there's only two elementary securities. There's an elementary security possibly for every state, and there's only two states. So for the zeroed state, for 39 cents, approximately 39 cents, we can buy a security that if the market goes up, we get $1, and if the market goes down, we get 0. For 44 cents, we can buy a security that if the market goes down, we get $1, and if the market goes up, we get 0. So that's how much each of those would cost. Okay. So now, just as a comment, what does the first security, the one that starts off at $1, and then at some point in the future it turns into $1.20 or $1.20. What does that sound like is going on? It doesn't have to be a security, it doesn't have to be a stock. It could be something that you can, anything you can put your money into, and then later on.
Like fixed income?
This is, yeah, it looks like money market, like it's something that's going to be guaranteed 20%, because this market only has two states, and no matter what state it is, you're going to get 20% more than you put in the first place. So it kind of sounds like this is almost cash. This is almost like putting money in the bank. And then the second one looks more like a stock, like you could win and you could lose. That's a little bit more like a stock. So suppose this was a market that existed, and we decided we wanted to build a put option on the stock. Let's say the first one's cash and the second one's stock. We want to construct a put option on the second one, the second security, with K equal to $2. Okay, with a K equal to $2, what would it end up, what would we pay today? So a put option with K equal to $2. That means whatever happens, so we're buying a put option. And it could either go, the underlying stock could be worth $2 or the underlying stock could be worth 50 cents. And if we're buying a put option, we're getting everything below $2. Okay. So what's the payout for us? The payout is either 0 or $1.50. Right? Right, that's the payout for us. So we could, so how much would you pay? So the question now, with the information you're given, how much would you pay for a put option with a strike price of $2? So how could we figure that out in this market? Now we could figure out the risk neutral price if we knew these probabilities, right? But let's say with this example we don't. So like we've done an example before where we said what's the price of a put option, and we knew like this was 50% and this was 50%. So there was a 50% chance we would get nothing, and a 50% chance we would get $1.50, and so therefore it's worth 75%, and then we might have to discount it back, so it might be worth 65 cents or something like that, right? We've calculated before like that. But now we don't have these probabilities, but we'd like to know, yeah, so what's new is we don't have these probabilities, but the new piece of information we have is because we're now using two different securities, we've done all this stuff. We can, independent of the question that's being asked, we could buy as many units of the first elementary security and as many units of the second elementary security as we want. They cost this much money each. So what does a $2 put option, what's its payout? If the market goes up, you get paid nothing. If the market goes down, we get $1.50. Can we replicate that payout? Can we buy stuff, not a put option, but buy stuff that will behave exactly like a put option? Can we buy stuff that if the market goes up, we get 0, and if the market goes down, we get $1.50? And that would be exactly like a put option with a strike price of 2. Does that make sense? So wait, so a put option with a strike price of 2 on the second security. So the second security is like a stock. You pay $1 today. If the market goes up, it's worth $2. If the market goes down, it's worth 50 cents. If you were to buy a put option with a strike price of 2 on that security, if the price goes up, you get everything below $2, which is nothing. Right? Puts, you gain. Right. Everything below, you get paid. So you'll get 0 up here, and what would you get if the market goes down? If you have a $2 put option,
$1.50.
you would get $1.50. So these are with a put with a strike price of $2. You'll get these payouts, either 0 or $1.50. So the question that's being asked is, how much would you pay right now for a put option that will 1 year from now get these two payouts? Can you simulate these two payouts using the elementary securities? The first elementary security says for 39 cents, you pay 39 cents right now, you're going to get either $1 or 0. This elementary security says for 44 cents, you will either get 0 or $1. Now, can we buy a combination of these two securities in any amount we want that has a payout of 0 or $1.50? And if we can, then we've exactly replicated the $2 put option. So again, a $2 put option will pay 0 in this state, $1.50 in this state. And we want to know what's the fair price to pay today for that payout. So if we buy 0 units of this thing, because we don't want to get paid out if we go into the upstate. We only want to get paid, we're trying to simulate the $2 put. So if we buy 0 units of the elementary security that pays us $1 in the upstate, and we buy 1.5 units of the second elementary security, then what will the payout be? If we had 1.5 of these and 0 of these, if the stock market goes up, we get 0. If the stock market goes down, we get 1.5 times $1, which is exactly this payout. So we would buy 0.39, whatever it was, plus 1.5 units of the 0.4416. They're both 16. And this comes to what? This would cost us right now 0.66 4416 times 1.5 is 624. Right? Okay. So for 66 cents, we can replicate the put option with a strike price of $2. That sound right? We could pay 66 cents today. We buy 1.5 of these. So again, an elementary security, the idea is we take the overall market and we say, if the market goes up, I want to know how much, I want to buy a security that if the market goes up, I get $1, and if the market goes to any other state, I get 0. That's called the first elementary security. Then if the market goes into the second state, and this only has 2 states, if it goes into the second state, I get $1, and if it goes into all other states, I get 0. And that I can pay 44 cents and get that payoff. So for 39 cents, I can buy a thing that if the market goes up, I get $1, and if the market goes down, I get 0. And for 44 cents, I can buy a thing that if the market goes down, I get $1, and if the market goes up, I get 0. And now I can pretty much, like we did last time, I asked you how much money do you want up here, and you said like $8 and $5, whatever number you said, we just buy that many units of it, and we figure out how much it costs. We could, if the market is complete and we can make every elementary security, then we can have any payout we want. If I wanted a payout that said, you know, $8 here and $1.50 here, I'd buy 8 units of this and 1.5 units of this. I could just buy as many of these elementary securities as I need, create a big basket, and get any payout I want. So all a put option with a strike price of $2 is a particular payout where you get 0 here and $1.50 here. I can actually, we could set these numbers to anything and I can price it. I could come up with a price to get any payout you want. You could make this $3 and this thing $8. You could make these numbers any number you want. And I'll be able to figure out how much we have to pay today to get that payout. So a $2 put has a payout of 0 here and $1.50 here. Okay, we'll take 0 of these and 1.5 of these. So we'll take 0 of the first one and 1.5 of the second one, and it costs 66 cents, 66.24 right now to exactly replicate a $2 put option. So the price of a $2 put option would be 66.24, given this market. So this is a world where there's only 2 stocks and 2 states. I can now tell you what a put option would be on this second security. Okay, now suppose we bought the stock. Suppose we bought the stock. Suppose we bought. Oh, I'm sorry, yeah. Suppose I said to you now, what is the interest rate in this market? What is R? These 2 stocks exist in some world where there's an interest rate. What is the interest rate? Well, one way we can figure out the interest, well, it might be intuitive for you to just see it looking at what's in brown. Can you kind of guess at what the interest rate would be? What's that? Right, because there's one security that no matter what state you go into goes to $1.20. So you could, suppose that wasn't the interest rate. Suppose that was some other stock that has this property that no matter what happens it becomes $1.20. Suppose the interest rate was not $1.20, that'd be an arbitrage, right? Because you could borrow money at, let's say the interest rate was 19%. You could borrow money at 19% and buy this stock, and then a year later, take your $1.20, pay the bank back $1.19, and pocket $1. So the interest rate would have to match this. Even if this is not the risk-free interest rate, you know, if this was not the money market price, then the money market price would actually be like a third security that's not showing up. It would have to be 20%, otherwise there'd be an arbitrage. But suppose you didn't see that right away and we wanted to calculate what the interest rate is. We could say, suppose we buy suppose we buy one share of the second one, which is number one, and one put with a K of $2. Suppose we did that. What would our payout be a year from now? If we go to the upstate, the stock is worth $2. I'm sorry, what would our net worth be a year from now? If we go to the upstate, the stock is $2 and our put is worthless. So we're worth $2. If we go to a downstate, our stock is worth 50 cents and our put is worth $1.50. So no matter what state we go to, we're worth $2. Right? So if we do this, if we buy a share and a put, no matter what happens, 1 year from now, we're going to be worth $2. So first step, we calculated what the price of a put is, and we used the fact that we didn't know these probabilities, but we had this information about the market. We were able to simulate the put option. So we simulated a put option and figured out what its price was. The price of a put option, the fair market price of a put option was 66 cents, 66.24. Now we're saying, hypothetically, suppose we bought one share and one put option. 1 year from now, what is our net worth? Our net worth is going to be $2 no matter what state the market goes to. How much did it cost us today to get? So now the question I'm trying to solve is, what's the interest rate? Suppose you didn't see that 20% right off the board and you wanted to just calculate the interest rate. We could buy a share and a put, and 1 year from now we're going to get $2. What do we have to pay? How much would we have to pay for a share and a put? We would have to pay, how much is a share today? The share is $1, and the put, like we said, is 66 cents. So we pay $1.6624, and 1 year from now we'll get $2, guaranteed. So what's the interest rate here? How do you calculate interest rate again? 1.6624 times 1 plus R equals $2. What is R? R equals, R equals what? $2 minus 1.6624. I'm subtracting. This is like the first class. What do we say? Trying to solve for R.
The total divided by 1.6624.
1.6624. Right? I'm taking 1.6624, subtracting from 2.
No.
Yeah, that's right.
Oh.
Right? Yeah, okay. And what is this? Anyone have a calculator? This better come out to be 20%. Because of it. What? 20.3?
Yeah.
Oh, maybe that's just because of some roundup errors. But it ends up being 20. Was it 20? Oh, 20 point, okay.
23%.
So it's like that. But this is actually because I didn't make this decimal go. If I made it go the whole way, it has to come out to be 20%. It would what I'm saying is it would have to come out to be this 1.2. If it was even slightly off, then we could, if the real interest rate was slightly more than 20%, there'd be an arbitrage. We could not borrow money. We could borrow the stock, sell it for cash, put the cash in the bank, a year later collect this much interest, and then rebuy the stock for 20% make. you know, this little part here. So the interest rate part of this question would have to be 20% because of that 20%, the 20% thing that you saw, you know, this thing. There was one security which ends up looking like money market that goes to 1.2 regardless of what the market does. That looks like you're just investing the money in the bank and getting a guaranteed 1.2. Okay, so now, what would the risk neutral price be of, okay, now let's just decide that that one is cash. So the expected value of cash in that example was what? What did we, if you, now what I'm doing is I'm just going ahead and I'm saying, this one is cash and this one's a, you know, a stock. So what is the expected value of the cash? Okay, what is the expected value of the cash one? That's going to be 1.2. And what is the expected value of the stock? The expected value of the stock was what? Now let me, is it read a page here? What is the expected value of the stock? The stock could go to $2 or could go to 50 cents. To know the expected value, we'd have to know these probabilities, right? So now, we weren't given them, now we can calculate them. So we'll make this a P, and this one will be Q, which is equal to 1 minus P. Okay. So, what would this be? This would be 2 times P plus 1 minus P times 0.5 equals what? .5 P plus 0.5. When does that equal 1.2? That sound right? And so then P equals 1.2 minus 0.5 over 1.5, 0.7 over 1.5 equals 0.4606. And then Q equals 1 minus P equals 0.5333. Okay, so if we took those, wait, what are these numbers? Okay. So this ends up being 0.4666, and this ends up being 0.5333. These end up being what's called the risk-neutral probabilities. If these were the probabilities of going to each state, then this vector and this vector are the risk-neutral prices for all those securities. Okay. Okay, now let's do another example. Suppose we have a security that goes 1, 1, and goes to 1, 2, or another state. And these states are not necessarily the high ones or up states and down states. These are just different states now. So suppose we had this opportunity. The first stop, whether we go to this state or this state, stays at $1. The second stop, in one state goes to $2 and then the other state goes to $3. Does anything like jump at you about this? Like what would you say is the interest rate in this world?
There isn't one?
there should be no interest rate, because if there was an interest rate other than zero, you could borrow money and then put it in this security or do the reverse. So if there's one security that pays the same amount, that has to match the interest rate. What about the other security where you, so clearly, for the first one, we could buy as many of these we want, or we could borrow money and buy these, or we can sell these, meaning we borrow the stock, sell them, get cash, and put it in a bank that's going to return the same money we give to them and then return the stock. So we can buy or sell that security. Okay. So what about the security that says if you buy one of them today, you'll either get $2 or $3? What would,
Positive interest rate.
this would be like a really good thing to,
Or risk neutral person.
well, I mean, what,
You would jump all over it.
you'd jump all over this one, and where would you get the money from? You don't even, obviously, if the interest rate was so high that maybe you're hoping you hit this one, like if you ended up in this state, you'd be losing, because the interest rate is so high, that could be a problem, but it looks like there's no interest rate. So there's something very off with this model. So, let's see, if we tried to let's try to calculate the elementary securities. So if we did this, theta 1 plus 2 theta 2 equals 1, and theta 1 plus 3 theta 2 equals 0, we would end up with theta 2 theta 2 equals -1 and theta 1 equals 3, which means elementary security 0 equals $2. For a $2 fee today, I could get $1 in this state and $0 in this state. So that would be, you'd have a tough time getting someone to try to pay up that kind of money. Why would you pay $2 today to get $1 up here and 0 here? You'd be losing money. And then if we did the one for E1, theta 1 plus 2 theta 2 equals 0, theta 1 plus 3 theta 2 equals 1. Solve this simultaneous equation. We would, if we subtracted, we would get theta, if we subtracted this way, we would get theta 2 equals 1. And therefore, theta 1 equals equals 1. Theta 2 equals 1. 2 plus something equals 0. This would be -2. All right? Okay. And then the elementary security for the second elementary security, this one, would be 1. We would want to buy, we'd want to buy 1 unit of the second thing and -2 units of the first thing, which would mean we would pay -$1 right now. So so what this is saying for this market, what this is saying is, if the market goes, if you wanted to have a security that pays $1 when the market goes up and 0 when the market goes down, you would pay $2 for that right now. But nobody would ever do that. You wouldn't pay $2 so that you have a shot at getting $1. And if you want to buy a security that pays 0 when the market goes up and $1 when the market goes down, you receive $1 right now to do that. So somebody gives you $1, and then who knows, you might even get another $1.
It seems like the expectation is that the market's going to go down or something, right?
Well, this is like, it's beyond that. It's like, it's, yeah, the whole world would be dumping their money. It's not even money, you receive money. You receive money betting the market will go down, and then if it goes down, you get even more money. So this is, it's win-win. So what I'm saying is, for a market with an arbitrage, there ends up being an arbitrage. When you start, actually you had brought this up last class, last video. you said, you thought that one of these prices was a negative number, and I was saying, no, it has to be positive, because if it was negative, then you're receiving money, and in the future, you will never be billed anything. You may receive more money. So that would be an arbitrage. So these would always have to be positives. So if you ever calculated the elementary security prices, and one of them came out negative, that means your market, that's everything in red here, your market has a built-in arbitrage in it. And the arbitrage here, I mean, it's pretty obvious in this one. In other examples, it might not be so obvious, and you'd have to go searching for the arbitrage. But in this one, it's pretty obvious. We can buy this security and be guaranteed to come out ahead. So we could borrow money from the bank, and the banks are apparently charging no interest. So we could borrow $1 from the bank, and a year from now we owe the bank $1. We buy this security, and we're going to either have $2 or $3, and then we pay the bank back. So we're going to either make a profit of $1 or a profit of $2, and it'll never cost us anything. So this market has a built-in arbitrage in it. So complete markets do not have an arbitrage. Every elementary security, we can get the price of it, and the prices are always positive numbers. Okay, and then I'll go over a two-stage example. And so suppose we had a security that, suppose we had two securities that are currently priced at $1 and $4, and 1 year later they could either be 1 or 8, and 2 years later they could be either 1 or 16. If the market goes down 1 year later, it'll either be $1 or $2, and if the market goes down again, it'll be $1 and $1. And the market could, after the first year, go up and then the next year go down, or the market could go down the first year and the next year go up. So there'll be a middle state where it goes back to 1 and 4. Okay, and this is sometimes called a lattice.
I was just about to ask that. That would be considered a lattice. Because your picture, they're not necessarily connected. They don't need to be.
Yeah, so in other words, the up, down, and down, up merge into one node. If this was two separate nodes, which we could do, we could say, like, for some reason, if it went up and then down, you'd better off than going down first than up. If that was the case, this node would be split, and then this would be called a tree. But if the nodes merge, then it's called a lattice. Okay. So, what does this really mean? It means 2 time units later, we could either get this payout, this payout, or this payout. So it's really like this 3 states 2 years from now. It could be this state, or this state. So, suppose we decided to say the probability of hitting this state is P, the probability of hitting the last state is Q, and what's the probability we hit this middle state? With P, you know, if this is P and this is Q, and there's a 100% chance we have to hit one of the states, this would end up being 1 minus P plus Q. So there's 3 different probabilities. The probability we're up here, the probability we're down here, or the probability we're in the middle. Okay. So what if we wanted to find, right, does this make sense? Right, if we're starting at this state, and we're ending in one of these 3 states, and we happen to have this intermediate state that got us there, but we're going to end up in one of 3 different states. There's a probability we'll hit this one, probability of this one, and this one. They all should add up to 100%, because we have to end up in one of those 3 states. We're going to assign the letter P to this one, Q to this one, and then this is what's left over. So if P was 20% and Q was 20%, this would have to be 60%, right? Okay, so what if our question was, find P and Q so that this lattice is a martingale. A martingale. What was a martingale again? A martingale said that where you expect to be at any point in the future is where you currently are. So how would we do this to have this be a martingale? It would end up being, a martingale for the second security. A martingale for. So I'm gonna let the first one be cash, and I'm gonna let this one be a stop. So what would P and Q have to be? So the P's and Q's are not on here. They're not here. They're just out here. What would P and Q have to be for, so that it's a martingale for the stock? What would we have to have happen? The stock could be worth $16 here, $4 here, and $1 here. But we want the expected value to be 4. A martingale, by definition, its expected value stays the same. At any point in the future, its expected value is what it currently was. So we would want $4 to equal 16p plus 4 times 1 minus p plus q plus 1 times q. If we could find p's and q's that make this equation make sense, then it's a martingale. Right? It's $4 now. It's going to be expected to be $4 in the future. That would make it a martingale. So there's the P times $16, this times $4, and this times $1. Average them all together. This should equal 4. So the answer to this ends up being, we end up having many answers. And the answers are like this. Answer 1 could be P equals 0.1, Q equals 0.4, and then 1 minus P plus Q equals 0.5. That answer would make it a martingale. A second answer could be P equals 0.01, Q equals 0.04, and 1 minus P plus Q equals 0.95. That would also make it a martingale. So there's actually a collection of answers, and the way to say it would be pi, 1 pi, 2 pi, 3. The vector equals epsilon times 1, 4, and 1 minus 5 epsilon, for epsilon between 0 and 0.2. So does it make sense that there'd be a family of answers? So for example, if this was 10% and this was 40%, 10% of the time you get 16, 40% of the time you get $1, and the rest of the time you get 4 again. That would work. That would make it a martingale. So really, whatever this probability doesn't matter because it matches the original number. It's just that this going up here has to be, going down here has to be 4 times more likely than going up here. And then this could be the remainder.
All right.
That kind of makes sense? So what we're really trying to do is we're trying to come up with P's and Q's to make this a martingale. That if you invested $4 today, you can expect to have $4 2 years from now. And so for example, this is 10%, this is 40%, and this is the remaining 50%. you're expected to have $4 2 years from now. If this was 1% and this was 4% and this was the remaining 95%, is it? Right, that would also be a martingale. So there's actually, it's kind of like, the answer ends up being, as long as this is 1 times something and this is 4 times that same thing, and this guy in the middle is the remainder. That's where, this looks like a complicated thing, but it's not. That's what it's really saying. It's saying
Pi is used as portfolio.
pi is used as,
Like, why is pi in there?
yeah, that's true. I should have let, this should be PQ and the thing in the middle, right? Yeah. That's a good point. That's just the notes where I got them from. But this should be P, Q, and 1 minus P plus Q. So as long as you can use infinitely many of them, as long as Q is 4 times P, and the thing in the middle is the remainder. And there's going to be a range where you can't go outside of this range. So, for example, if this was, if epsilon was 0.2, this would end up being 80%, this would be 40%, which means this thing in the middle is 0%. And then beyond that, it doesn't make sense. We don't want to have the percentage being over 100%. Right, we wouldn't want this, like, it wouldn't make sense to have this. It wouldn't make sense for this to be 20%. Wait, this has to be 4 times 2. This could be 20%, this could be 80%, and this could be 0. But this couldn't be 30% and this be
120%.
100, wait, is that right? 4 times it, right? Yeah, 120. This can't be 30, this is 120, and this is the remainder. Well, now we've used up our whole 100%. So that's really all that's where this epsilon is coming from. Between 0 and 0.2, any factor multiplying this would work.